Let's begin with the basics, the smallest building block in the universe. It is not a brick, it is not a cell, it is called an atom. What is the structure of an atom? An atom is tiny, too small to see, but inside it holds three powerful particles. Say them with me: protons, neutrons, electrons. Protons have a positive charge. Neutrons are neutral, no charge. Electrons are negative. Where are they found? Protons and neutrons live in the center, called the nucleus. Electrons move around the nucleus, like planets around the sun, in shells or energy levels. So remember, nucleus, protons, and neutrons. Outside the nucleus, electrons and shells. This structure never changes. Every atom follows this rule. Now let's define elements, mixtures, and compounds. An element is a pure substance made of only one type of atom. Just one. Nothing else. Examples: gold, oxygen, carbon. A compound is when two or more different atoms join together, chemically. Water is a compound made of hydrogen and oxygen, H2O. You cannot just pull them apart easily. They're bonded. A mixture is different. It's a blend of substances that are not chemically bonded, like sand and salt in the same jar. You can still separate them. They're mixed, not combined. All right, let's go over that one more time. An element is made up of just one kind of atom. A compound consists of different atoms joined together chemically, and a mixture contains different substances that are not chemically joined. Now let's move on to solids, liquids, and gases, and their particle models. In a solid, particles are packed tightly together. They don't move, they just vibrate in place. That's why solids have a fixed shape. In a liquid, particles are close together but can slide past one another. That's why a liquid takes the shape of its container, but keeps the same volume. In a gas, particles are far apart. They move freely and quickly. That's why gases spread out and fill any space. Picture it. Solid equals tight and locked in place. Liquid equals flowing but connected. Gas equals zooming everywhere. Next, a powerful rule of science, the law of conservation of mass. In any chemical reaction, mass is never lost. Mass is never gained. The total mass of the reactants equals the total mass of the products. Example: hydrogen plus oxygen gives you water. 2 grams of hydrogen plus 16 grams of oxygen equals 18 grams of water. Always, every time. Even if gas escapes or bubbles form, mass is conserved. It's not magic, it's conservation. Say it again, mass is conserved, always. Let's move to 3 important reactions: combustion, oxidation, and thermal decomposition. First, combustion. That means burning. Combustion happens when a substance reacts with oxygen and gives off heat and light. Example: burning wood or petrol. Wood plus oxygen gives you carbon dioxide, water, and heat. Second, oxidation. Oxidation is when a substance reacts with oxygen and gains it. For example, iron plus oxygen produces rust. Rusting is a slow form of oxidation. Third, thermal decomposition. This means breaking something down using heat. Thermal means heat. Decompose means to break apart. For example, calcium carbonate breaks down into calcium oxide and carbon dioxide when you heat it. Combustion means burning with oxygen. Oxidation means reacting with oxygen. Thermal decomposition means breaking with heat. Now let's talk about the atmosphere. What is the structure and composition of Earth's atmosphere? The atmosphere is made of gases, mostly nitrogen and oxygen. Nitrogen is about 78%. Oxygen is about 21%. The rest, about 1%, includes argon, carbon dioxide, and other gases. So remember, 78% nitrogen, 21% oxygen, 1% everything else. These gases surround the Earth and make life possible. Now let's talk about the carbon cycle. How is carbon recycled in the Earth's atmosphere? Carbon is everywhere. In your body, in the air, in animals, in plants, in rocks. It moves around in a cycle, like a loop. Here's how it works. Plants take in carbon dioxide from the air during photosynthesis. Animals eat the plants. Carbon goes into animals. Animals breathe out carbon dioxide during respiration. When plants and animals die, they decay. Sometimes they turn into fossil fuels over millions of years. Then, humans burn fossil fuels. That releases carbon dioxide back into the air. So, photosynthesis takes carbon in. Respiration and combustion release carbon out. Decomposition and decay return carbon to the Earth. That is the carbon cycle. Let's lock it in with a rapid recap. Atom structure. Protons, which are positive, and neutrons, which are neutral, are in the nucleus. Electrons, which are negative, are in shells. An element is one type of atom. A compound is chemically joined atoms. A mixture is physically combined and easy to separate. Solids have particles packed tightly. Liquids have particles that slide past each other. Gases have particles that spread out and move fast. Conservation of mass means no mass is lost or gained in reactions. Combustion burns with oxygen. Oxidation gains oxygen. Thermal decomposition is broken down by heat. The atmosphere is 78% nitrogen, 21% oxygen, and 1% other gases. The carbon cycle moves through photosynthesis, respiration, combustion, and decay. And now you're ready. You are not just learning science. You are learning how the world works. Every breath you take, every fuel we burn, every tree that grows, it's all chemistry. You've got this.